Okay, in this video we're going to cover the headstay or the forestay or the thingy out the front that holds all the thingies out the front bit. So last time we covered why we're replacing our stays, and more importantly why we actually need to also replace our headstay. If you look at that previous video, it explains why we are actually replacing all our stays at the same time and the reasons that are associated with that. So go and check that one out if you're a little bit lost as to why we're talking about having to replace this stay. The sails in front of the mast, there are two types. There is a hang-on style, which is just a stay, usually with either a metal or a soft hank that hangs onto the sail and it gets hoisted up. A bloke by the name of Ted Hood supposedly invented the furling, the modern day commercial furling system, and it's quite cool because that means that we can furl the sails forward of the mast, furl them around the stay and put them away quickly, and also deploy them quickly. And we can actually do this without having to go onto the bow of the yacht. So that's all really good. So this video is going to cover furling sails, and in particular furling sails such as jibs that hang on to the structural, or that are attached to your structural stay. So let's have a look at what a roller furling system that sits over a structural stay is and what most people have on their boat. It's pretty simple. It sits over the structural stay, so we cannot actually see the turnbuckle and the metal stay inside here. You can see that it turns around and around, and we use a rope here to actually mechanically turn this drum around, which is attached to all of these aluminium tubes here. And these aluminium tubes run all the way up the forestay, and these actually have the sail attached to it. So the sail goes into a groove here. So we normally call these aluminium tubes foils because they're foil shaped. And the sail slides into this, and when the aluminium tube rolls or rotates, it wraps the soft fabric sail around it. Okay, that's the basic principle of this furling system, that we have a furling system or unit that sits over the structural stay. So there are two things doing two completely different jobs. We have the stay inside holding the mast up, and then we have the furler on the outside of it furling the sail away. So we're moving away from this style of furling and moving towards a completely different system right from the ground up. So the two actually, while they do the same job, they do it very differently. It is a bit of a becoming the norm in the bigger multi-hulls to go with the system like what's currently on Outnumbered because of all the advantages, particularly weight-wise, with it. So we're just using that same tech and bringing it down into Pikea, and we'll actually go through why there's a big advantage with that system versus this system. Okay, so if we look at it component by component, let's start right at the bottom. So right down here at the bottom where it attaches to the boat. At the moment, there is a turnbuckle inside this furling unit, and that turnbuckle is directly attached to Pikea's longeron via a great big 19mm nitronic pin. Okay, so that connects the headstay to the boat and to the mast. So our stay and our turnbuckle sit inside of this assembly. So it's all nice and protected, yeah? No. That means it's all inside, cops all the salt water and everything when we're sailing, but we can't rinse and flush it out very easy. And also we cannot inspect it. So always nervous about what's going on in here. Now there is a turnbuckle in here, and there doesn't always have to be a turnbuckle in here. A lot of headstays are fixed length when they're wire. Sometimes, and in our case, I replaced a like for like. It had a turnbuckle there. I didn't know what the rake of the mast had to be, so I wasn't confident in making it fixed length, so I kept the turnbuckle there. So the turnbuckle is there not to tighten your rig. The turnbuckle is there to adjust the length and the rake of your mast. Okay. Now, separate to the forestay, you can see there's stainless steel drum here with its pin through it. Now this is actually just to control the furling unit separate to the actual stay. So there is a lot of metal here and a lot of pins and a lot of connections, and you got to allow one pin this way, another pin that way for all the articulation and everything for when the stay moves, because the stay is not static. It doesn't stay in one place. When you load up the forestay with a sail on it, it bends. It doesn't bend, it sags. And when it sags, that means that the attachment point alignment all goes out. So you have to have articulation at the connection points, because this stay does not stay straight. Okay. Right, next part, the drum. And inside the turnbuckle. So we're going to look at two things here. But first we'll look at the drum. The drum has its sole purpose of spinning the bit that furls the sail away, which is the big torque tube, the foil, the bit that the sail attaches to. Okay, this is pretty simple, and the bearing, it's got bearings inside here to allow it to rotate. Okay, so the stainless steel tube down here is fixed, and it's got bearings on it, and those bearings then allow this drum to spin, and spin nice and smooth for a 35-year-old furler. Now above the drum we see another swiveling component, and this is where we attach the tack of the sail. So that's the bottom front corner of the sail attaches here. And why does this swivel independently, you ask? Well, that's because the sail moves independent of the aluminium foil, in that when you tack, the sail will be shaped one side and then shaped the other. So there needs to be a small amount of articulation to allow for the sail shape and movement relative to where the bolt rope goes into here. This can't actually be fixed. It turns into a bit of a cock up. So more moving parts, more metal. So this is how we attach the tack of the sail. Then we move into the big main torque tube, or the foil. This is where the grunt of the work is done. So this is the bit that turns and wraps the actual sail around it. Now the sail is attached via a bolt rope 99.999% of the time. You'll have either one or two bolt rope grooves here, and the sail slides up inside of it. And this, when the aluminium turns around, has the ability to then roll the sail around it. This tube is really good because it's a metal tube. Its torsional stiffness is really high. So when you rotate down the bottom here, the amount that it rotates at the top is very close to being the same. There are small differences, it's less than an eighth of a turn usually, but it's very efficient and very effective at when you turn the drum down the bottom, the sail turns at the top within a sparrow's fart. Okay, so it's very, very good. It's also quite strong, and we'll get on to the subject of reefing and furling. And if you thought I hated A-frame main sheets a lot, get me on the subject of furling headsails.
Don't reef.
Don't reef your headsail. Then there is another critical component that we need for this system, and this is the head swivel. Now, when the sail is attached to all of this, the sail is going around and around this, but we don't want the halyard that pulls the sail up to wrap around and around and around as well. So we have this double swivel arrangement here. So again, we have the lower swivel to allow the small amount of articulation between the sail in the groove and the head itself. And then we have the big halyard. So this part of the swivel actually does see some load, because this one actually has the halyard tension going through it. Because the halyard's not directly attached to the sail, these swivels and their balls actually try to get pulled apart by the sail pulling down and the halyard pulling up. So the swivel here actually sees full halyard load. So that's our jib halyard. So this pulls it up and down. So this head swivel unit, when it's not all tied in place, slides up and down with the sail to hoist it and drop it. So this head swivel is a key part, like I was saying, to making sure that you have a halyard to hoist the jib and nothing gets tangled up. If it's working, nothing gets tangled up. There's been a lot of situations where it all gets tangled up because someone didn't read the instructions properly. So they're the basic components of this headstay arrangement. Now, I'll cover how this actually works in relation to the stay inside. Okay, then there is the wire inside there. Now, I was talking about this metal tube down here and the bearings that allowed everything to spin around here, right? That's okay down at this end for managing and allowing this drum down this end to spin around something. As we go up the stay, we need something for this aluminium torque tube, or the foil, to spin around. So what do we use? We use the stainless steel wire inside as part of the bearing assembly. How's that done? At each join, because these aluminium extrusions can't be the one single length all the way up because it's too hard to manage. They're about 1.5 meter sections. Some companies run longer, some run shorter. So about every 1.5 meters, there is a join in this aluminium foil. And at that join, there's an internal joiner. And that internal joiner usually has either a plastic or a rubber bushing that it uses to spin around on the metal stay itself. That is 110,000,000% why you cannot use a synthetic stay with this Furler arrangement, okay?
Those bearings will wear out.
Yeah, exactly. Those plastic or rubber bearings that are inside there will tear apart the synthetic stay. It is not a stainless steel metal for it to run on.
So what about a DIY stay?
Okay. A DIY forestay in synthetic and furling, you cannot do it. Simple as that. There is quite a few reasons for that. One, you're already compromised with a braided rope structurally in the longitudinal and in the actual tension. Okay, you've got braids that are all where the fibers are off axis, they're not straight up and down, so it's compromised in that the stay is going to be a bit stretchy, and it's always going to settle with a bit of creep. Every time you pull it tighter and tighter, those strands try to get a little bit straighter each time. So as a structural component, it's not great. Then as a torque component, because the torque component, you actually want those fibers as far away or as close to 45 degrees as possible. But of course, we're wanting a braided rope to be structural in the longitudinal and try and be as close to 0 degrees up the stay as possible. We don't want that to be at 45. Now, because the fibers are not at 45, it makes it an absolutely terrible torque rope. So to use a braided rope as a torque rope, it just doesn't work because it doesn't meet either of the two criteria. It sits in the middle and does none of the jobs. So it doesn't work. Now you're thinking, oh, Shane, but I can go and get some cover and I can cover the DIY thing on the outside. No, you can't. And there's two really good reasons for that. One, when you get the sock and you put the sock over the structural forestay, one, it's not going to be anywhere near enough material. Two, the fiber angle is absolutely not going to be the right orientation. It's still going to be either too flat or too straight.
When you say not enough material, you mean just chafe protection?
Not chafe protection, but there is actually just not enough fiber there going around. You'd actually have to put like 4 or 5 covers on there. But people will be asking, and I'm pretty sure people have tried as well, because there's many people on this planet and they do a lot of experimental things.
Us included.
Us included. So yeah, you actually need a bunch of covers to get enough material on the outside to work as the torque, the synthetic torque tube around the synthetic stay inside. Okay, so Anna's going to put the picture of a synthetic torque tube which has the really dark brown PBO inside, and then it has a lighter yellow Kevlar casing on the outside. So it actually is replicating what's here, where you have the structural stay inside and then you have the furling torque component around the outside of it. The biggest difference is they actually live together in unison and they both turn together in unison. They don't live separately and they don't move independently of each other. Okay, so that's the big difference. So they do the same job, but they achieve it very differently. Yeah, so don't waste your time and money trying to DIY a headstay, torque headstay. Oh, the other reason is you'll never, ever, ever get the braided sock tight enough over your DIY stay to actually be effective as a torque stay. When the guys wrap it on the machine, they wrap it tight, really tight. So there's a lot of pre-tension already taken into that torque jacket when they wrap it around the structural stay. Okay, well, that covers all the components and what they are for and basically how they function. Okay, so let's have a look at this system and how it differs to the system most people are accustomed to seeing and using, and what we're changing from on Pikea to future Pikea. So we'll start at the bottom like we did with Pikea and we'll look at the attachment. So on this boat, it has a carbon chain plate with a metal pin as its primary attachment. Same as Pikea, orientation's different, but that doesn't really matter too much. But the actual attaching to the longeron through a carbon material with a metal pin, same, nothing fundamentally different. What is different is what is used to make the connection between the forestay and the pin. You can see here that it uses a synthetic loop. Now, this has a lot of advantages and it has some disadvantages too. Tell me it's not 100% foolproof. So let's start with the advantages. 1, it's really light. 2, infinite articulation. There's no binding pins and plates and things like that. This can move and flop and go wherever it likes. It's got infinite articulation, so that is great. The issue, of course, again, is chafe and stretch. The usual culprits for synthetic rigging, whether it's in the actual structural stay or as a connecting loop. Same things, same problems, but it fixes one big issue, and that's the articulation and metal on metal wearing and grinding, corrosion. Yeah, I could go on with the list as long as your arm about metal and how bad it is as a material in the marine environment. Likewise, I could go on as much as about that, about synthetic and how bad it is with regards to all its downsides. So they all have their pros and they all have their cons. One of the big pros, though, is it weighs nothing. Now, this is where the really big change comes in. So the attachment point and the connection, fundamentally the same as what's on Pike here. From here up is where there is a massive fundamental difference in the systems. Okay, it might look the same, but I can tell you it is not the same. We have a furling unit here. It's so big and pre-wound that I can't actually spin it for you. This furler unit takes the full headstay, forestay, front stay, stay in the front of the mast that holds the flappy things, all of the load that's associated with it. There is no couple of plastic ball bearings in there and allowing things to rotate. This has the full welly. On Pike here, that's the full 6 tons going through it. On this boat, it's the full 12 tons from memory. I'm sure this is a 12-ton unit. So, serious load. So there are serious bearings inside there. They're not little tiny plastic jobbies. They are industrial, metal, hardened steel jobbies to deal with the loads and still roll with all of that load. So this furling unit is fundamentally completely different to the other style of furlers, because this furler unit has to do 2 jobs. It has to carry the full structural headstay load, and it has to be able to deliver rotation, whereas those 2 jobs were separated on the other system. Now, what the furler unit is attached to is our headstay cable. And now this is a torsional headstay cable, okay? This is very different to the side stays because it has the extra element of the fibers wrapped around the outside of the structural core, and it has a lot of them. All right, so when you get a torsional cable made, the diameter is always much larger than the side stays and the lowers, or the shrouds, cap shrouds. So you can see that the stay is actually connected directly to the furler, and when this turns, the stay directly turns, and then the stay is now responsible for turning and wrapping the sail around it. It's no longer the aluminium tube, so the stay has to do 2 jobs. It has to be, 1, structurally strong and stiff and not stretch, and it now also has to be a torque member. So it actually has to deliver torque so that when you twist it down here, it doesn't twist the top. In reality though, when you do a bottom-up furling system like this, when you turn the furler down the bottom here, it doesn't quite turn quite as much at the top. What we do is we actually end up with what we call a preload in the cable, because we're not using a metal, which has really low stretch in torsion, especially when it's a nice big circle, where you'll get approximately half, in some cables, if they're not great, 1 whole turn difference, and in some really bad ones, you'll get 2 turns. So if you have a good furling cable, particularly a structural headstay, if you've got more than 1 turn, it's not so good.
Yeah, so in summary, the comparison is that with
that our current setup on IKEA, where you've got the metal foil, all you've got to do is just pull on that furling line, and it will just twist the whole foil, and it will furl your
twists it.
sail. It'll
Yep.
twist your whole sail for you.
All in unison. Yep.
Whereas situations where you've got these sort of just you're relying on these synthetic stays, there isn't actually any foil there. So
Sure.
there's nothing. You sort of, as you're saying, you pull on that bottom furler unit, and it starts twisting from the bottom up.
Yep.
So that is, like, there are tricks to get around that with the pre-tensioning.
Well, it's not an issue on the Headstay because the cable's kept so tight. One of the biggest issues when you are furling with code zeros and A3s and flying sails right out the front is you struggle to get cable tension.
Yeah.
And that cable tension is crucial to the torque because if you wind the cable actually wants to get shorter. And if you haven't got tension in it, resisting that shortening, it just keeps spinning and making itself shorter instead of delivering the torque to the top.
Yeah.
But because our forestays have so much tension in them,
We don't get that.
we don't suffer from that problem so much.
Yeah.
So that's why a synthetic headstay torsion cable, we're talking less than, 1.5 turns between the bottom and the top, and even less in really good systems, because we carry a lot of headstay tension. Okay.
Which is why it's critical to know how lengthy your forestays are. This
Right. Yes. So instead of going to the swivel bit, let's talk about the lack of a turnbuckle. Now, lack of a turnbuckle is not
It's not the end of the world.
not unordinary. It's not exceptional. It's not the exception.
It's not out of the ordinary.
It's not out of the ordinary. That's the words I'm looking for. So a lot of boats still run fixed length metal forestays where there is no turnbuckle on the wire or the rod at the front. Okay. They actually just run a fixed length with an eye and a fork or a toggle at the bottom, and you have a fixed length forestay. Not a problem. It's the same with the synthetic setup. We don't put a turnbuckle in 99.9% of the time because one, you can't fit it. And two, generally we're talking about boats with rigs that are at the higher end, and the people working on them and working everything out are a little bit more switched on. So the tolerances all come down and everyone builds to tighter tolerances so you can run a fixed forestay and end up with the correct rake. That's all it is. So it's not abnormal. But also with these loops, if I want to change the rake of the boat, I just change the length of the loop, either at the bottom or at the top. And I can actually move this furler up and down the cable, depending on which loop I make shorter and longer. So there is actually a lot of freedom there to change the rake and move things around to improve performance when you're at the really high end of the performance scale, like moving your furler up and down to change the way that the headsail sheets is a whole nother thing as well. So that's that bit about turnbuckles. Okay, let's talk about the head swivel. You'll notice there's a sail on here and there is no head swivel down here like what we showed on Pikea. Even with the sail down, there is no head swivel down here. Okay, there is no head swivel that slides up a structural forestay, because you would end up with a part rotating inside of a part and a part moving on a part where the halyards potentially chafe on the headstay. Now, there are some exceptions to that, and I have actually looked into designing head swivels for standard halyards arrangements on these types of things, and there are a few companies that are now starting to offer them, but they do come with a lot of caveats. So how do we pull the sail up and down if we don't have our normal halyard system? And how do we attach the sail to the cable? These are all good questions, you ask. Well, let's start with the halyard situation. In the case of this boat, at the swivel itself, the swivel has a halyard incorporated into it itself. And we'll do a very similar thing with Pikea, where the halyard will actually hang off the top eye of the cable. You'll see here there's a big eyelet like this. There's one of these at the top as well. And there will be a pulley block that's spliced into there, and the pulley block will hang down here, and the halyard will go, and that becomes our halyard block, no longer in the mast. It's all now incorporated with the sail and the front cable. Okay, so the halyard also rotates with the stay. So on this particular boat, there is actually a halyard lock at the swivel as well. So you hoist the sail up, and there's a strop between the bullet lock and the top of the sail, and it goes on the lock, and then the halyard is loose, and that halyard runs loose down the inside of the pocket of the headsail. Now this system, some of you who sail beach cats will know exactly what I'm talking about. And there is actually also a lot of dinghies out there as well that have a zipper pocket luff where you hoist the sail up the headstay and the halyard comes back down inside the pocket of the headstay. So that's completely not foreign to a lot of you that have sailed proper boats. So this boat has exactly the same system. It has soft hanks that hank onto the structural forestay. Then it has a pocket that goes over the top of that with a zipper on the side that hides the soft hanks and incorporates the halyard, which is on this side here, the halyard inside it, so that everything is contained neatly, nothing's on the mast, everything is contained in and on the headstay. So how do we adjust the luff tension? Well, with the other boat where you got a halyard, you just adjust the luff, the halyard, and that adjusts the luff tension. On this boat, it's done via a lashing down at the tack here. So if you want to adjust it, you got to untie it, tighten it, relash it. If you want to loosen it, untie it, ease it, retighten it. Which is, some people go, oh no, that's no good. Well, we're in a whole different realm of rigs where we're using good sails and all the rest of it, so we don't have super stretchy sails. So the amount of times we adjust this, like in this boat, never. It's never been adjusted in 2.5 years. So, and likewise with Pikea, with the carbon headsails that we've had, it was set and forget. I literally had the halyard splice that I could slip to a certain thing, and I would get it to the right length, clip it at the mast as a fixed length, and then had a small lashing at the bottom here, which I then did the fine tune adjustment, and I would rarely ever adjust it once it was settled. Yeah, so that hopefully covers the differences between the two systems and their different components, and their same components, and how they differ from each other.
Yeah, and the thinking behind where we're heading to, because I mean, we were supposed to take you all to Fabrica for this video, but I thought it was really important to sort of cover this forestay.
Yep.
Before we
it's a big subject.
And I feel like we'd be jumping the gun if we didn't at least sort of address what's going on and what the idea is.
Yep. Now, I want to touch on one very big fundamental difference between this system and the system that's on Pikea and that most people use. And that's reefing the headsail. You cannot reef the headsail with this type of arrangement. Okay?
Reef your headsail.
Yes.
From a sail making.
From a sail making point of view and from a sailor point of view. And I'll just lightly touch on it in a moment. Okay. So with this, from a sailing point of view, sailor's point of view, is that we change gears by putting away one sail and bringing out another one. So we'll put the big sail away and we'll put out a bigger sail or bring out the smaller sail. That's how we change gears. It is way more efficient, but it does mean you have to carry extra sails. But I can't stress enough, it's way more efficient, and it ends up cheaper because you don't trash the sails at the speed you do when you reef your headsail. Okay, so when you reef a headsail, you completely kook the shape. The sail shape goes out the window when you reef it. A headsail, and a good modern one, has not got a constant camber through it. So it's a constant curvature. So that means that the shape of the sail is not the same curvature from the front to the back. It is an aerofoil shape. You have more curvature at the front and less curvature at the back.
From a sail making point of view, you're reinforcing the bits that get the load along the luff. And
Yes.
you're going to reef it to halfway. You no longer got any of that reinforcing.
Yes. Yeah. So 1, the shape goes out the window. 2, structurally all the loads get completely cooped up because you're no longer pulling on the sail in the right directions. So you've got a double whammy of this is all bad. So I do not like reefing headsails because it's terrible, absolutely terrible. You're better off reefing a headsail by lowering it on the headstay and slab reefing it like you do the mainsail, because those sails are actually designed to do that. They have reefing points in them and they are set up to do that. So if you want a headsail that is reefing, do the slab reefing thing, not the furling one. In our books is a very simple subject because 1, we've looked at it for a very long time and we've worked with it for a very long time. But 2, hopefully that explains to people the different components we're using and how we've actually simplified the system. And you can see why it's so much lighter as well, that there is no furling unit stuff. Even if these plates were aluminium like the other one, it's still way lighter because we haven't got all the aluminium torque tubes going up. So this system is much, I can't even tell you how much lighter it is. I probably could tell you how much lighter it is, but
You might need to.
but yeah, it's epically lighter, and it's incredibly reliable. So that is why we're moving to this simplified version for Pikea.